Welcome to chemistry classes. Today's topic is significant figures. Significant figures are also called as meaningful digits. These are useful to represent an experimental data in reliable manner. These significant figures have 7 rules. One has to follow 7 rules. This is rule number 1 among the 7 rules. Okay. Rule number 1 is all the non-zero digits are significant. All the non-zero digits are significant. Here, let us take a number. Let us take an example. 1974. Okay. If one asks us how many significant figures are there in 1974 means there are, we can say deliberately, there are 4 significant figures. There are 4 significant figures because all are non-zero digits here. Is it clear? This is the first. Rule number 2. The rule number 2 is zeros in between two significant figures are significant. Okay, let us see one example. When you consider the number 2024, if one asks us about significant figures, okay, let us see what we have to say. This is significant, this is significant, okay. This is also significant, being these 3 are non-zero digits. When you consider the 0, as per the rule, 0 in between two significant figures are significant, okay. Here 0 also significant. So we can say that in this number there are 4 significant figures. 4 significant figures, okay. Rule number 3. Zeros right side to the decimal point are significant. Zeros right side to the decimal point are significant. Let us consider one example here. If you have a number 100.0, okay, if you have a number 100.0, here how many significant figures? Let us see. 0 right side to the decimal point is significant. Is it clear? So this is significant figure. Okay. 1 is a non-zero digit. It is a significant figure. The zeros in between two significant figures are also significant. So how many significant figures are there in this number? 100.0 means significant figures in this number is equal to 4. Okay. Let us see the fourth rule. Tailing zeros are not significant. Tailing zeros are not significant. Okay. Let us see one example. 27,000. Okay. Here these zeros are called as tailing zeros. Okay. These are not significant. Okay. How many significant figures of this number means there are 2 significant figures. Being these are tailing zeros, these are not to be considered as significant. Okay. There are only 2 significant figures in this number. Is it clear? Rule number 5. Leading zeros are not significant. Leading zeros. Okay. Let us see one example. If you have a number okay, these are called as leading zeros. Okay. These are not significant. Leading zeros are not significant. Only these 2 are significant here. Is it clear? So number of significant figures in the given number is 2. Okay, I am going to do 6th rule. Zeros left to the decimal are not significant. let us see one example. 0.007. Okay. So here 0 left side to the decimal point. This is 0 left side to the decimal point. It is non-significant. Okay. So being this 0 is non-significant, these are also considered as non-significant numbers. Okay. Only one significant number is here, 0.007. How many significant figures are there? Significant figure is equal to only 1. Okay. Being this 0 is non-significant. Is it clear? These zeros also becomes non-significant. Okay. The seventh rule of significant figures, this governs scientific representations. Here what is meant by scientific representation? If you want to represent a bigger number, then you have to approach a systematic procedure to represent it in a simple manner. Is it clear? సో మీరు ఏదైనా సరే ఒక పెద్ద నెంబర్ని రిప్రజెంట్ చేయాలి అనుకున్నప్పుడు మీరు దాన్ని ఒక సింపుల్ మేనర్లో ఒక సిస్టమాటిక్ ప్రొసీజర్ ప్రకారం కనుక రిప్రజెంట్ చేస్తే దట్ ఈస్ సెడ్ టు బి సైంటిఫిక్ రిప్రజెంటేషన్. హియర్ ఓకే, ఇస్ ఇట్ క్లియర్? నౌ when you want to represent Avogadro number, okay, Avogadro number means here if one want to represent Avogadro number in scientific manner, and all of the scientists and all of the researchers and students are representing Avogadro number like this, 6.023 into 10 to the power of 23. This is Avogadro number. This is scientific notation. This is scientific representation of Avogadro number. If one want to represent this in simple manner, అంటే దీన్ని సైంటిఫిక్ అప్రోచ్ లేకుండా ఒక సిస్టమాటిక్ ప్రొసీజర్ ఫాలో కాకుండా రిప్రజెంట్ చేసేటప్పుడు 6.023 రాసిన తర్వాత 23 జీరోలు పెట్టాలి. ఓకే, 23 జీరోలు పెట్టాలి. That might be come from this end of board to that end of board. అంటే బోర్డు ఈ చివరి నుంచి ఆ చివరి వరకు రాసినా కూడా ఆ 23 సున్నాలు మనం పెట్టడం కష్టం అవుతుంది ఒక్కొక్కసారి. సో టు అవాయిడ్ సచ్ కాంప్లికేషన్స్ the scientific representation method was introduced. According to scientific representation, so the number with maximum magnitude, the number with the highest magnitude can be represented by following this. Okay, n into m power n. Okay, so let us see one example here. If you have a figure 12,000, okay, if you want to represent it simplest form, this can be represented 1.2 into 10 to the power of 4. Okay, here n is equal to 1.2, m is equal to 10, small n is equal to 4. Okay, so in such a way we can represent simply the bigger numbers. If there is another 0, this will become 10 to the power of 5, like this. Okay, so this is the representation of Avogadro number when we follow such manner. Okay, then let us see how many significant figures are there in Avogadro number. Okay, so being only 4 significant figures we can find in Avogadro number. Okay, this value is not to be considered. Okay, so here for such type of examples or for such type of numbers, significant figures in Avogadro number is to be considered as 4 only. No need to worry about this. If one asks us how many significant figures are there in Avogadro number, deliberately we can say that there are 4 significant figures. Okay, let us see another one. 1.6 into 10 to the power of minus 19. 1.6 into 10 to the power of minus 19. How many significant figures are there? Significant figures are here is 2 only. You need not worry about this. Is it clear? So that is about significant figures present in scientific representations. Okay. Let us see how many significant figures are the example present in the example taken. Here 1.2 into 10 power 4 is the simplest representation. Then significant figures are 2 only. Okay, significant figures are 2. This one and this one. Okay, you need not to consider 10 to the power of 4 when you are representing significant figures, when you are counting significant figures. Is it clear? These are the 7 rules which has to be followed to represent experimental data or anything population data or anything else. We have to consider these rules. Okay, that is about significant figures. Now let us see some exercises based on this. Okay, I will give some numbers. You try to find the significant figures and then keep them in comments. Okay, thank you. See, this is the exercise I am keeping for you in this video. Okay, please accomplish the exercise, complete the exercise and keep the answers in comments. Okay, thank you.